Good afternoon. This is the second of two videos on section 1.7 in your textbook entitled Transformations of Functions. You'll recall from the previous video that we have already talked about two types of transformations, translations and reflections. In this video, we're going to talk about the third and final type of transformation that you guys need to be aware of, and those are called stretches and shrinks. Now, these are what we call non-rigid transformations. And the reason that they're non-rigid is because now we're not going to keep the same shape and size of the function. The graph itself is going to be stretched or shrunk. And so it won't look quite the same as it did. In translations and in reflections, we've flipped them over, we've moved them, and that sort of thing. But the size and shape of the function, the original function, remains the same. Here, it's going to change. Now, a horizontal stretch or shrink happens when you manipulate the value of x, all right? And you see the function here, y equals f of x divided by c. The x itself is divided by c. And so this means that it's a horizontal move because we're manipulating the value of x, so left or right. Now, if the value of c that we're dividing x by is less than 1, that's going to cause a stretch of the original function. If that value is greater than 1, it's going to cause a shrink of the function. Now, I do want you to be aware that we can also look at this as f of the quantity c times x. All right, but if you use this idea, then the stretch happens if c is greater than 1. Oh my God. And a shrink happens if c is less than 1. Now, if we take the entire value of the function f of x and we multiply it by a number c, then if the value of c is greater than 1, we stretch the entire thing vertically. If the value of c is a fraction, in other words, less than 1, then it will be shrunk by that factor of c. All right? And so, again, manipulating the x value causes a horizontal stretch or shrink, and multiplying the f of x value causes a vertical stretch or shrink in this case. Okay, so let's look at an example here. We've got this example. Compare the graph of each function with the graph of f of x equals the absolute value of x. All right, remember, absolute value means that we're looking at the value of x and just looking at its distance from the point 0, 0. So what I want you to do is to compare the two graphs here, or the original graph, f of x equals the absolute value of x, with h of x equals 3 times the absolute value of x, and g of x equals 1/3 times the absolute value of x. Now, in part A, we are multiplying the original function by a factor of 3. All right, and because we're multiplying f of x by a term, that means that the transformation is going to be vertical. It's the same thing for the 1/3 times the absolute value of x. We just have to determine now whether these vertical moves are stretches or shrinks. Now, this represents the function f of x equals the absolute value of x. All right, and you can see on the graph that if x equals 1, y equals 1, and if x equals -1, y equals 1, and so on, and so on, and so on. We just go continue on. The absolute value of 3 is 3. The absolute value of -3 is 3. All right, and hopefully you are familiar with this as one of the 12 basic functions that you've seen. Now, if for h of x, I multiply f of x by 3, all right, which is what I'm doing here. Well, I do it there, I guess. So g of x equals 3 times f of x. All right, what's that going to do to the original function? Well, if I multiply the value of y by 3, all right, if x equals 1, y is going to equal 3. And if x equals negative 1, y is going to equal 3. And so if I look at the graph of h of x equals 3 times the absolute value of x, I can see that this is a vertical stretch. Every point has moved up by a factor of 3. All right. Now, I've only moved up 2 units, mind you, but 1 times 3 is 3. All right, and negative 1 times the absolute value of negative 1 times 3 is 3. All right, and so I have vertically stretched this, the original graph, by a factor of 3. Now, for the second one, I'm going to do pretty much the same thing, except that now I'm multiplying it by a factor of 1/3. All right. This obviously gives me a value of c that is less than 1. All right. 1/3 is a fraction. And therefore, that's going to present a vertical shrink here. And so in this case, I'm going to decrease my value of 1 to 1/3 and my value of negative 1 to 1/3. And so what I've done here is a vertical shrink by a factor of 1/3. All right. So in the previous example, 3 times the absolute value of x, that was a vertical stretch. Here, I've got a vertical shrink. All right. Now, it doesn't mean that the entire picture gets teeny tiny or very big. It can mean that it just looks a little bit different. So don't be fooled by those terms, stretches or shrinks. All right, it really depends on what the original function is, all right? Especially in a case like this where we're dealing with absolute values. Okay, so h of x equals 3 times the absolute value of x is a vertical stretch. H of x equals 1/3 the absolute value of x is a vertical shrink. Okay, let's look at another example here. You're asked, in this case, to compare the graph of each function with the graph of f of x equals 2 minus x cubed. Now, if g of x is equal to f of 2x, then in this case, what we're going to end up with is g of x is going to equal 2 times, I'm sorry, that's not correct. It's going to be 2 minus 2x, oh, for the love of God, quantity cubed. And so g of x is going to equal 2 minus 8x cubed. Okay. Now, in this particular case, I'm multiplying the x cubed value by a factor of 8. All right. And so what this is going to do is actually give me, because of this 2 here, a horizontal shift in this case. And specifically, it's going to be a shrink, all right, because the value is greater than 1. Now, if I do the same thing here, h of x is going to equal the value of 2 minus 1/2 x quantity cubed, and that's going to give me 2 minus 1/8 x cubed. Now that, because the value of c is less than 1, is going to give me a horizontal stretch. So let's have a look at the original function. All right, the original function is the x cubed graph, and we first reflect it across the x-axis. All right, so we took the whole thing and moved it, inverted it, and then we added a factor of 2, which means that it went up by 2. All right, so a flip and a factor of 2. All right, from the original basic function, f of x, or a of x, equals x cubed. All right, we flipped it and we raised it by 2. Now, if we want to use the g of x term, g of x is f of 2 times x. All right, as I showed you in the last slide, this gives me 2 minus 8x cubed. And so what this is a horizontal shrink by a factor of 2. All right, that's what this 2 represents. All right, it's a horizontal shrink by a factor of 2. And if you look, everything has moved closer to the y-axis in this case. All the blue has moved closer to the y-axis, all right, to give us the red line in this particular case. Now, on the other hand, if we use h of x equals f times, or f of 1/2 x, that is going to give us a horizontal stretch. All right, the 1/2 in this case, all right, it's not 1 over 2x, it's 1/2 times x. Sorry about that. Equals 2 minus the 1/8 x cubed. And what that does is it gives us a horizontal stretch by a factor of 2. All right, this would be x over 2 if you really think about it. And you can see that the red line represents the new function h of x, and the blue line represents the original function. And so you can tell that the whole thing has been horizontally stretched by a factor of 2. Okay, and so there is the horizontal stretch there. Now, this is will conclude our discussion of section 1.7. And so, 2 things. First, I would like you for homework for the next class to do homework questions 1 through 69 at the end of section 1.7. Odd numbers only, and remember again that the answer key is in the back of your textbook for those odd numbered problems. But also please be aware that this is the last section of chapter 1 that we're going to discuss this summer. And therefore, your midterm exam is going to be the next class after we go over the homework assignment. And it will cover sections 1.4, 1.5, and 1.7. Okay, those all 3 of those sections. So there we go. I hope that you're ready for it, and I hope that you learned something.